smoke detectors. What are they? Um, Smoke detectors are there to notice those incipient products of combustion, the smoke. They're sensitive and quicker to respond than heat detectors, typically much quicker. And the negative of that, they are prone to false alarms and being influenced by a dirty environment. Your um, products of combustion, possibly in a kitchen, will set some off. A dirty electrical room or switchgear room may set them off or coat the insides of the detector and decrease their response rate. There's a bunch of different, not a bunch, there's a couple different types that are used. And most modern detectors have a programmable sensitivity level, and some actually have drift compensation. They actually can see the detector getting dirtier over time by and large, and then adjust the response. That usually happens for the addressable panels and with a smarter detector. So first type of smoke detector, kind of jump through here quickly. Ionization smoke detectors. It basically uses radioactive material, energizes the particles, which decreases the conductance. If that's noted, an alarm is triggered. Very useful for flaming type fires. Has largely been phased out due to the radioactive material that's in the detectors, and also due to the fire type. There's been a big push in smoldering. Although with the new UL 214, 268 testing standard, there's a lot of manufacturers that are putting both these and photoelectric in the same component. But photoelectric detectors actually is a little bit different because it uses a sensing chamber with a fixed light source and another photosensitive device somewhere in there. They usually use an infrared light, excuse me. Smoke enters the chamber where it disrupts the light flowing to the sensor or scatters the light so that basically the sensor sees less light coming to it. Very useful for sensing smoldering fires. Thus tends usually to be quicker in response time if you have a long fire growth time. Most detectors on the market today are this type. They're also cheaper. There's no radioactive source. It's just a light source. And then refer to SFPE, sorry, I forgot the E, for average obscuration alarm threshold values. Not something I think you'll be tested on, but worthwhile holding on to and bookmarking. Something to note here when you talk about smoke detectors, you may be asked on the test, is your spacing. Spot detectors, unlike heat detectors, spot detectors are nominally spaced at 30 feet. Smoke detectors, excuse me, or 30-foot spacing, which is 900 square feet. However, this is reduced in high airflow or obstructed construction. Okay, airflow, you have to reduce it by this chart. So if you have 30 air changes per hour, your spacing is down to approximately 250 square feet. You're at 60 air changes per hour, you're what, 125? So instead of having, 4 detectors in a 3,600 square foot area, you could be quadruple that value, depending on your airflow movement. It's also for obstructed construction. So waffle construction, large beams, peak ceilings, all those can be found in Chapter 17 in that section. And then I want to note here that in that section 2, they talk for locations when detectors are used for door releasing service. So if you have a smoke door, generally where you are, you're required to have smoke detectors in certain locations to release those hold opens. Another type of smoke detector is air sampling. These detectors use a fan to continuously draw air into that sensing chamber through a series of tubes. Ionization, photoelectric, maybe a combination, maybe a proprietary. These are more expensive, but generally they're a lot more sensitive due to continuous active airflow to the sensors. So they're always gulping air. A spot smoke detector is a passive device. You have to wait for the smoke to drift there if it ever does. A aspirating smoke detector will continually sample the air of the space and bring it back to the unit, so it's much more likely to notice products of combustion and also much quicker to notice those products of combustion. Note here, I remember this question actually being on my test, is that it is limited by transport time. So all aspirating smoke detectors must alarm in 120 seconds from smoke admittance into the chamber. So that is, I didn't quote this here, but that is in chapter 17, that it is 120 seconds until from the end of line sampling port back to the detector.